Hello and welcome to this video tutorial on holdings. This tutorial will be divided into three parts. We'll begin by looking, in the first part, we'll begin by looking at the different aspects of a hold, its major sections or parts, what they are called. And then once you're familiar with the hold, how it looks like, we'll move on to part two, the different sectors of a holding. How do you actually fly into one? The entries of a holding pattern. How is each entry flown? And then in the final part, we'll be looking at we'll be taking a more practical approach. We'll get into a multi-engine propeller airplane and in flight simulator and fly the entries actually, do it practically so you can know how it's actually done. So without any delay, let me go ahead and start in the first part. Let me bring my hold. So, what is a hold in the first place? Well, why do we need to hold? Sometimes in major airports or big airports where there's a large amount of traffic flow, it happens that sometimes there is no enough space because airplanes need to be separated by specific distances while they are in flight. And so sometimes the traffic amount of airplanes in the sky is too much that we need to stop the flow of airplanes to create the needed separation. And so airplanes fly into a holding pattern like this because airplanes cannot stop in midair. It has to be constantly flying so that it won't fall. So the airplanes fly into a holding pattern like this, keep circling in a racetrack. It looks like a racetrack, and until there is enough space for the aircraft to land, and then they leave the holding pattern and go onto the airport. So usually holds are done over a specific fix or a VOR or an NDB or an airport. It depends on how air traffic control suggests, gives you the instruction on where to hold. So we'll begin by looking at the very simplest way of a holding pattern. Let's assume we're going to hold over a specific VOR, let's say Charlie Victor Oscar VOR, doesn't matter, any VOR would do. There are two types of holdings. There is a standard hold and there is a non-standard hold. The standard hold is to the right, is right turns. That's a standard one. So the airplane comes into the racetrack and continues to fly constantly to the right turns. In a non-standard holding pattern, the airplane will be flying in the opposite direction. So it will be flying into this direction. Sorry, let me give this a little bit bigger. The airplane will be flying into this direction and continues to fly left turns. That's a non-standard hold. So standard hold is to the right, which is you're flying into this direction. You're always turning to the right, and the non-standard will be the one you're turning to the left, the opposite direction. So let's look at the beginning in a standard holding pattern. So if I get if ATC instructs us, for example, let me type here, for example, this is air traffic control instructs us to, for example, Egypt Air 665 hold over Charlie Victor Oscar VOR inbound course, let's say 270. This is how a specific holding instruction would be like. So we start in the beginning. You need to have a paper and a pen with you, so you can always, when ATC instructs you to fly a hold, if you're flying with an aircraft that doesn't have an FMS or an FMC, as some call, you need to have a paper and a pen. For example, if you're flying a gauge airplane, which has many gauges, it's not a glass cockpit aircraft, you need to have a paper and a pen so you can draw the hold on a paper, like we are going to do here in this program. And it is very important to do so. So I suggest you, if you don't have a paper and a pen, you pause now and get one. Alright, so we begin by drawing, once we get the instruction from air traffic control that we need to hold, we take the piece of the paper and a pen and we draw a racetrack like this one. And then the second step is we draw the fix that we're going to hold off, so hold over. So if you look here, Egypt Air 665, hold over Charlie Victor Oscar. So this is our fix. So once we draw the racetrack, we draw the fix that we're going to hold over approximately here. So if we this circle here with this dot is representing Charlie Victor Oscar VOR. The VOR that we are going to build our hold on. So alright. So once you draw the racetrack and the holding pattern, the next step is to identify or continue. This is the first step in the drawing. The second part is to continue to extend the lines. So if you're going to get a line here and extend this line in this way, and extend this line this way, and you write the headings of what the air traffic controller says. So for example, let's look at the example the aircraft ATC gave us. So Egypt Air 665, hold over Charlie Victor Oscar, inbound 270. So this is the inbound course, because we're going inbound into the VOR, going to the VOR. So the inbound course is towards the VOR station. So this heading, this is the same heading. This is heading 2. Excuse my writing. This is heading, heading 270. This heading. So this heading is 270. Now, the reciprocal or the opposite of this heading would be heading of 090. This is alright, sorry about that. Let's make it. Yeah. So all what I did is just wrote the inbound. The ATC gave us an inbound course of 270, and I drew it, and I put the reciprocal heading 090. We're going to need this, so make sure you put the numbers correctly. You always minus 180, or you add 180 to this number to get the outbound course. So this 090 is now outbound because you're going away from the VOR. So let's first a little bit change the color, and let's talk a little bit about the hold itself. So this section of a hold, the section in green, is the outbound leg, because you're going in an outbound direction. As you can see, I'm going now. If the aircraft is flying in this leg, it's going at the heading of 090, which is the outbound. So this section is now called the outbound leg, the section in green. And now, similarly, the section in blue here, which I'm gonna draw, is called the inbound leg. So because this is going, you see that the arrow is going towards the VOR station, and so this is going to be the inbound, and this is the blue one is the inbound leg, and the blue one, the blue one is the inbound, and the green one is the outbound. So just to make sure, the blue one is the inbound leg, and the green one is the outbound leg. All right. Now, the next step for us to do is to, once we do the heading 270 and the heading 090, extend both lines. The next step for us to do is to, let's get this here, is to draw this line. We take a line and draw it diagonally, as you can see in this area. Now, this angle here is about 70 degrees. Of course, when you draw it on a pen and a paper, it's not going to be exact, but just so that you know, this is a 70 degree angle. So if I want to know the heading here, in this line, now a difference of 70 degrees from the number 90 is 020. So this heading is 020. Now, why did I minus 90 from 20? Why didn't I just add? So it's heading 160. Now the rule says the following: if the line is going, you see, if we're here and we're going anti-clockwise, so I'm going into this direction, I'm going anti-clockwise, you subtract. So 90 minus 70, you subtract if you're going anti-clockwise. However, if you are going clockwise direction, so here in here, you'll be adding. So if this is 20 plus 70, it's 90 degrees. If you're going clockwise, it's adding If you're going anti-clockwise, you're subtracting. So let me, now we just need to figure out one more heading, which is this one. So we have, now 20 is the reciprocal, this number here is going to be the reciprocal of the 20. So 20 plus 180 or minus 180, whatever the number gets. It must be the number that we get, the result must be within 0 to 360 degrees. So I cannot say 20 minus 180 because that's going to be a negative number, and headings do not have negatives. And so we add this time. 0 to 0 plus 180 is heading to 0, 0. So this heading, sorry, is heading 200. So this is heading 0 to 0 and heading 200. So once you draw this on a pen and a paper, this is how you draw a holding. This is once ATC gives you an instruction, you should always do this before you fly the holding pattern. If you don't have if you don't have an updated aircraft with an FMS, if you're flying a propeller airplane, this is what you need to do. Okay, now this drawing implies to standard holdings only. So if it's a non-standard holding, there is a slight differences in the drawing. So this drawing implies to standard holds. Now, how did I know that the ATC instruction, this instruction here, is for a standard hold? The rule is as follows: if the ATC did not specify right turns or left turns, we assume it is a standard turn. So here ATC said Egypt Air 665, hold over Charlie Victor Oscar VOR inbound course 270. So he didn't say left or right turn, so I'm assuming always a right turn. If ATC wants us to make a left turn, he would say, okay, Egypt Air 665, hold over Charlie Victor Oscar, inbound course 270, left-hand turns, if he wants us to fly a left-hand turn. So once we, so this is how I knew that he wants us to fly turns to the right, a standard hold. Alright, so now once we drew the holding pattern, there is a couple of things that I need you to know. If we get, now this area here, if I just extend a little small line, let me get the correct line. Alright, let me just get it. Okay, so if the aircraft is here, so in this position, so you are in the holding pattern and you start to turn, and the aircraft is in this position now. It's continuing to fly into the outbound leg, but it is here at this position. Now, this position where the VOR station is exactly at your 3 o'clock direction. So it is exactly, if you can notice, this is a 90-degree angle. This position is called a beam. So the aircraft is a beam to the VOR. That means that the VOR is exactly to the right or exactly to the left of the VOR is exactly to the left or I'm getting guilty. Wait. So a beam means that the VOR is exactly to the right or exactly to the left. So I say it again. A beam indicates that the VOR is exactly to your right, or if you're flying a non-standard hold, exactly to your left. So in this position, the VOR, as you can see, is 90 degrees to my right, and so this position is called a beam. Let me write it down. This position is called a beam. Okay, so this is here. The aircraft is a beam to the VOR. All right. Additionally, let's talk a little bit about the times. So a holding, how much should I stay on the outbound leg, and how much should I stay on the inbound leg? How long my turn should be? So below flight level 140, which is 14,000 feet, or at flight level 140, the outbound leg should be 1 minute. 60 seconds, 1 minute. The inbound leg as well is also 1 minute, in case if you are at 14,000 feet or below, so flight level 140 or below. This green area here is 1 minute, and this blue area here is 1 minute. Now, how about the turns? when you turn the aircraft, how steep should you be turning? Well, you should be turning at a standard rate of turn. So that is 3 degrees per second. 3 degrees per second. 3 degrees per second, and it means that you're going to make a full circle. If you fly continuously, turn the aircraft, you're going to fly a full circle in 2 minutes. So one circle is 2 minutes if you fly 2 circles. But if you look at this black turn here, black curve, you can see that this is half a circle. So you should fly this turn from heading 270 here to a heading of 090 in this outbound leg. You should take 1 minute in your turn. Now, how do I know in my aircraft that this specific bank angle gives me 1 minute? If you look at your turn coordinator in your aircraft, so you must have a turn coordinator in your aircraft, which most aircrafts do. Let me give you a picture. Turn coordinator, yeah, give me a little bit. Yeah, here is a picture for a turn coordinator. So if your aircraft has a turn coordinator, which most aircrafts do now, this is a standard date. You can see that here it says 2 minutes. So you can see that when you turn your aircraft, the symbol of the airplane here will be turning also, will be banking to the right or will be banking to the left. So if when the wing makes that wingtip here matches with this dash on the right, then you're flying a standard rate of turn, a 360 degrees in 2 minutes. And you should also take into consideration that this ball in the middle should be centered, because sometimes when you make a turn, the aircraft might be the turn will not be coordinated. The tail will slip, or it will underturn or overturn. So you must make sure that the whole aircraft is flying in a standard rate. So you must make sure that the wingtip of this symbol, of this aircraft symbol, is matching with the white dash, and the ball is exactly in the middle. Now, what if the ball goes to the right or to the left? If the ball goes to the right, you input a simple rudder. Make a small rudder input to the right. So you move the aircraft rudder to the right a little bit just to make it centralized. If it goes to the left, also put a slight left rudder pressure so that the tail of the aircraft stays in coordination with the nose of the aircraft, and the aircraft itself flies a coordinated turn. It doesn't overturn or underturn while you're doing the turn itself. So 2 minutes for 360 degrees. How do I know? The wingtip should be to the dash and the ball should be in the middle. Alright, so if 360 degrees takes 2 minutes, so this is now 180 degrees, 1 minute. So I should be consuming 1 minute here, 1 minute in the green area, which is the outbound leg. Also, this is a 180 degree turn, so this should also take 1 minute. And finally, the inbound leg itself would also be 1 minute. Now, if we total this up, a holding below flight level 140, which is 14,000 feet, so a hold at 14,000 feet or below, let me write it down, hold at 14,000 feet or below should total up to 4 minutes. So any hold at 14,000 feet or below, 4 minutes. Why is it 4 minutes? This is 1 minute the turn, 1 minute also here in the outbound, 1 minute into the curve, into the turn to the inbound leg, and 1 minute onto the inbound leg itself. So a complete total of 4 minutes for the whole holding pattern. That is at 14,000 feet or below. Excuse me. Now let's see what differences will this be if we are at above flight level 140, so above 14,000 feet. Above 14,000 feet, the only difference is that there's a green arrow, which is the outbound leg, and the blue arrow, which is The inbound leg will be, instead of 1 minute, it will be 1.5 minutes. So 1 minute and 30 seconds. So 14,000 feet, above 14,000 feet, the only difference in timing is that this outbound leg, the green section, is going to be 1.5 minutes instead of 1. And the blue section is going to be 1.5 minutes as well, instead of just 1 minute. And the turns are just a standard rate, 1 minute here and 1 minute here. Additionally, pilots, when pilots fly a hold, as an accuracy check, so if this takes a 1 minute, 1 minute, 1 minute, this should also be taking 1 minute. So if you're flying these 3 parts correctly, and your timing in the hold is correct, you should find that your inbound leg will automatically be 1 minute. So if you're flying here is a 1 minute correctly, 1 minute here is correct, 1 minute here correct, this automatically will be 1 minute. However, if you take a little bit longer in this green section, the blue section will also be a little bit longer. So if this is 1 minute and 15, this is going to be 1 minute and 15. If this is a little bit short, this is also going to be a little bit short. So once you finish your turn, once you start to turn here, go to outbound and turn to the final leg of the hold, or final area of the hold, which is the inbound section. If this totals up to 1 minute, then you know you have a good hold. If this doesn't total up to 1 minute, it's a little bit less or a little bit more, then you know that you have some winds, maybe headwinds here or tailwinds here, and we will be looking at that in later sections. So to summarize all what we did, we just explained how to draw a hold when you have an instruction. So ADC instructs you to fly a hold. This is what you do on a pen and a paper. You must have a paper and a pen with you. Draw the hold as we showed, and then in the next part we'll be looking at how exactly do we enter the hold. So if we're coming from this, if we're coming from this direction, or if we're coming from here, how do we actually get into this hold correctly? Because there are ways that you need to look, or where is the aircraft coming from, so that you can enter a hold correctly. So in the next part, we'll be looking at how the different entry. There are 3 entries to hold, so we'll be looking at that, and how is each entry flown. So I'm going to stop here, and I'll see you in the next part.